This video is for parallel lines and transversals, featuring alternate interior and alternate exterior angles. So our essential question for these notes is, how do I use alternate interior and alternate exterior angle properties to solve for missing information? So recall, as we've been doing this, that when we have two parallel lines cut by a transversal, that we get 8 special angle relationships. One relationship does not necessarily exclude or eliminate any other of the ones that we're talking about. So as we look at this, we have alternate interior angles. So alternate means opposite or across. Interior means inside. So we're looking at angles that are on the opposite side of the transversal, but inside the two parallel lines. So examples of that would be 3 and 6, and 4 and 5. These are alternate interior angles. So when we do this, the measure of angle 3 is congruent to the measure of angle 6, and the measure of angle 4 equals the measure of angle 5. When we look at alternate exterior angles, those are on opposite sides of the transversal again, but this time they are outside the two parallel lines. So that's like 1 and 8, and 2 and 7. So that means that the measure of angle 1 equals the measure of angle 8, and the measure of angle 7 equals the measure of angle 2. So we've discussed lots of other relationships that angle, for example, 8 has. Angle 8 can be a linear pair with 6 and 7. It is vertical with angle 5, and it is corresponding to angle 4. So all those different relationships still hold, even though we've added another relationship, alternate exterior angles. So when we look at number 1, this is just identifying the relationship. We're calculating the missing angle and justifying our relationship. So we look for the symbols that indicate that these are parallel lines, because these relationships only hold true for parallel lines cut by a transversal. And then we notice that we have two angles inside the parallel lines. So these are alternate interior angles. That means that angle X equals 62 degrees. For number 2, we have angles that are on opposite sides of the transversal, but these angles are on the outside of the parallel lines. That means that these are alternate, I'm using abbreviations now, exterior angles. That means that X equals 77 degrees. So we have justified and solved for the missing angle. As we progress through the examples, these involve more algebra, and it's a 3-part question. We're looking for X, but we're also looking to find the missing angle, which is the one that's in bold. And we're still justifying our answer. So when we look at the first example, they are inside the parallel lines, and they are on opposite sides of the transversal. That means that these are alternate interior angles. That means that negative 7 plus 7x equals 5x plus 15. So we subtract 5x from both sides. Negative 7 plus 2x equals 15. We add 7 to both sides. 2x equals 22. X is 11. So here are 2 out of the 3 pieces of information. Then we come up to the top, and it appears that negative 7 plus 7x is in bold. So that's 11 times 7 minus 7, which is 70. If we plug it in on this side to check, 5 times 11 is 55, plus 15 is also 70. So there's our check. For number 4, we have angles that are on the outside of the parallel lines and on opposite sides of the transversals. So these are alternate exterior angles. That means that 37x plus 4 equals 39x minus 2. We're going to subtract 39x from both sides. Negative 2x plus 4 equals negative 2. Subtract 4 from both sides. Negative 2x equals negative 6. X equals 3. 2 of our 3 pieces. If x equals 3, when we plug it into this bottom piece, 39 times 3 minus 2. 39 times 3 is 117. Minus 2 is 115. So if we use the same logic and say that 37 times 3 plus 4, 37 times 3 plus 4 is also 115. And they should be the same because alternate exterior angles are the same. Let's do 2 more examples. So I have angles on the outside of the parallel lines on opposite sides of the transversal. These are alternate exterior angles. That means that 4x plus 22 equals 6x minus 2. Subtract 6x from both sides. Negative 2x plus 22 equals negative 2. Subtract 22 from both sides. Negative 2x equals negative 24. X equals 12. So when we substitute that in, 4 times 12 plus 22, 48, 50, that should be 60. Sorry, 70. Because when we plug in over here, 6 times 12 minus 2 is 70. The last example, we have angles on the inside of the parallel lines that are on opposite sides of the transversal. That makes these alternate interior angles. That means that 4x plus 10 equals 6x minus 10. Subtract 6x from both sides. Negative 2x plus 10 equals negative 10. Subtract 10 from both sides. Negative 2x equals negative 20. X is 10. So that when we plug that in, that's 4 times 10 plus 10. That's 50. And when I check the other side, 6 times 10 minus 10 is also 50. So when we're looking at angle relationships for parallel lines cut by a transversal, there are relationships between the alternate interior angles, opposite sides of the transversal inside the parallel lines, and alternate exterior angles, opposite sides of the transversal outside of the parallel lines.